Hello and welcome to this another video lecture series on communication engineering. I am Ramji, working as an assistant professor in the Department of Electronics and Communication Engineering at GCE Tanjavur. In this lecture, we will be discussing about spread spectrum, PN sequence, direct sequence spread spectrum, and frequency hopping spread spectrum. What is spread spectrum? The spread spectrum is developed for military applications. It is a technique used to provide a secure communications by spreading the signal over a large frequency band. There are two techniques to spread the spectrum: direct sequence spread spectrum and frequency hopping spread spectrum. In direct sequence spread spectrum, the incoming data sequence is directly spread by PN sequence. In frequency hopping spread spectrum, the data sequence is modulated by FSK mixed with PN sequence, frequency hops, and then it is spread. Here PN sequence is essential in spread spectrum. What is PN sequence? PN sequence is a noise-like high-frequency signal. It is not a completely random, but it is generated by well-defined logic. There are some important properties of PN sequence. There are balance property, run property, and correlation property. In balance property, the number of ones is always more than the number of zeros. The run property, the maximum length sequence generated by the feedback shift register of length n, the total number of runs is 2 power n minus 1. The correlation property, the autocorrelation function of maximal length sequence is periodic and it is binary valued. So if we take this is a PN sequence 001111, the length of the sequence based on the number of flip-flops in the feedback shift register. If the length of the shift register is m, then the length of the sequence is 2 power m minus 1. If m equal to 3, so we have 7 PN sequence. So this is an NRZ form of the PN sequence, and we can prove this three properties: balance property, run property, and correlation property. In the case, in balance property, the number of ones is greater than number of zero. Here we have 4 ones and 3 zeros. In the run property, the formula is 2 power m minus 1, where m is 3, so 2 power 3 minus 1, that is equal to 4 runs. So if we take this sequence, there are 4 runs: 0, 0 is a run 1, 1, 1 is a run 2, 0 is a run 3, and 1 is a run 4. How to generate the PN sequence? PN sequence can be generated with the help of the shift register and feedback logic. So this is the length of the shift register. If the number of flip-flops in the shift register is 2, we have to choose 2, 1 as a feedback tab. If m equal to 3, we have to choose 3, 1. If m equal to 4, we have to choose 4, 1. If m equal to 5, we have to choose either 5, 2 or 5, 4, 3, 2 or 5, 4, 2, 1. Similarly for 6, 7 and 8. So this is a structure for three a feedback shift register with m equal to 3 with the feedback tabs 1, 3. That means the output of S1 is added with the output of the S3, then it is given to input of the S1. So this is a output from the feedback shift register. So we have S1, S2, S3. So initially we have to assume S1, S2, S3. 1 is assigned for S1, 0 is S2 and 0 is in S3. So after doing one circular right shift, we can get this values, that is S1 value is given to S2, S2 value is given to S3, and this S1 and S3 are added, that is XR, that is given to S1. Similarly we do all the values, then after we can get the after repeating if we get the repeated sequence, we can stop and we can get this is the PN sequence 00 111 01. In direct sequence spread spectrum, so this is a block diagram direct sequence spread spectrum. So binary data sequence is given to the NRZ level encoder. This encoder converts decay into bipolar NRZ waveform, and the PN sequence generates and encode this sequence in bipolar NRZ signal. The multiplier will multiply this two signal B of t and C of t. The output of the multiplier is M of t, that is given to the DPSK modulator to get direct sequence DPSK signal. So this is a M of t. So this is a B of t signal, NRZ form of B of t signal. This is a NRZ form of C of t signal. If we multiply, we can get this M of t signals. This M of t is given to the BPSK modulator. So this is a high frequency analog signal. Okay, the phase of the high frequency analog signal will be changed based on this M of t signal. So finally we get direct sequence BPSK signal. At BPSK direct sequence BPSK receiver, the received signal Y of t is applied to the multiplier, which is also supplied with a locally generated carrier. The output of the multiplier is then applied to the low pass filter. The bandwidth of low pass filter is equal to M of t. Then this M of t is given to the second multiplier. So this M of t is then multiplied with the PN sequence C of t. The output of the multiplier is given to the low pass filter. The bandwidth of the low pass filter, that is equal to B of t. Then this B of t is given to the decision device to get the data sequence. In frequency hopping spread spectrum, the input binary, this is a block diagram of the frequency hopping spread spectrum. The input binary data is applied to the MRA FSK modulator. This modulated output is in particular frequency depending upon the input signal. The output of the FSK modulator is then applied to the mixer. The other input to the mixer is a particular frequency from the frequency synthesizer. The output of the frequency synthesizer at a particular instant is a frequency slot or a frequency hope. This hope is mixed with the FSK signal. The output of the mixer is a sum of frequency component, FSK signal, and the frequency hope from the synthesizer. The frequency hopes or slots given to the mixer are generated by the frequency synthesizer. The input of the frequency synthesizer are controlled by pseudo noise generator, that is a PN generator. The T successive bits of PN sequence generator control the frequency hope generated by the synthesizer. From T bits of PN sequence generator, 2 power T frequency hopes are generated. The total bandwidth of output signal will be equal to sum of the individual frequency hopes. At the frequency hopping MRA FSK receiver, the received signal is then applied to the mixer. The output of the frequency synthesizer is also given to the mixer. The sum and difference frequency generated by the mixer. These difference frequencies are exactly the MRA FSK signal. This MRA FSK signal is given to a non-coherent detector to detect the particular symbol transmitter. There are two types of frequency hopping spread spectrum: slow frequency hopping and fast frequency hopping. In slow frequency hopping, several symbols are transmitted in one frequency hop. In fast frequency hopping, several frequency hops are used to transmit one symbol of data. Next lecture will be discussing about multiple access techniques. Thank you.